So we can start with the question. It's gonna be like a one-on-one kind of Q&A questions, just about like what you do and how you kind of implement like environmental sustainability into like your job and stuff.
Sure.
Okay, so we can start with how you got your job and what were the background to leading up to your job in Caresoft, and what were your educational backgrounds?
Okay. My name is Samy Panneerselvam. Um, I work for a company called Caresoft Global. We are a benchmarking and cost reduction company, and we do have a strong engineering background. We've been doing engineering service for past 18, 19 years now. I've been with Caresoft for the past 14 years now. Prior to Caresoft, I was with InCAT, which was part of Ford. Uh, and prior to InCAT, I was part of Global Tech, which is based out of Farmington Hills, Michigan. I did my master's and PhD in Wayne State, Michigan. My master's was based on finite element modeling, and then my PhD was based on composite materials. So that is a quick background about my education and my working background. Um, do you want to focus predominantly on carbon footprint or air pollution
Yeah.
on?
We like to
Okay.
focus mainly on like the carbon footprint and like of course your education and the compost materials and just like how you got interested into that and like how like you started in that field.
Okay. So in carbon footprint.
Yeah.
So so every OEM has carbon footprint targets. So for example, if you take we are into automotive sector. So automotive sector has it, aerospace has it, medical has it. So uh, the global intention is we need to become carbon neutral in 2035 or 2050 or whatever it's going to be. We cannot just rapidly go down from 4% to 0% in 1 year or 10 years. So it is going to be a gradual downgrade of carbon utilization. So for us, for automotive sector, we have carbon targets for 2025. And then, so how we calculate carbon footprint is when you have a vehicle launch, for example, let's take Ford, if they are releasing a new vehicle, their vehicle should have a carbon footprint of say zero point 0.023 or 0.035. So they need to publish that fact so that they will know that, okay, previously in 2020, they were manufacturing vehicles which had a carbon footprint of 0.045. Now they have come down by 1%. So gradually they will be a carbon neutral company in 2035. So that is a graph they're trying to follow. So, so that is how we got into carbon footprint because we work with companies like all the big OEMs in States, Europe, Asia, Korea, all over Japan, globally. So everybody has their carbon targets, and then when we work with them on the products, it can be benchmarking, cost reduction, product development cycle, whatever it is. So carbon footprint is part of every cycle. For example, say you design a door, right? You can use steel, you can use aluminum, you can use composites, whatever it is. So if you are trying to lightweight a vehicle, because now we are putting a battery, you need a bigger range, wider range. So you need lightweight your vehicle as lightweight as possible. So if you want to do that, normally people say, hey, let's jump from steel to aluminum, right?
Mhm.
Because steel is heavier, aluminum is lighter for the same volume. So people say that let's do it. But when you move from steel to aluminum, your carbon footprint is going to go up for the same volume because aluminum production has a higher emission of carbon compared to a steel production. So even though you're going to lightweight it, you're going to increase the carbon. So how do we optimize this? So that is where companies like us, who are all supporting all major OEMs, has to incorporate carbon footprint in part of the design, part of cost reduction, and the whole process. So that is how we came into carbon footprint, and that is how carbon footprint is an integral part of our all programs.
So you basically kind of like decide what is beneficial like money wise and also for, like for the earth and try to find a good balance in between because you said it's
Right.
more lightweight and it's but it is a higher carbon footprint.
Right. So I need to take the optimized route. I should not
Mm.
go for So if I reduce my carbon footprint, my cost will go up. So if I
Mhm.
go for composite, my carbon footprint is going to go down, but my cost is going to go up. If I go for steel, my cost is going to go down, but my carbon footprint will be optimized. So aluminum. So I need to find optimized graph, which will be like we are reducing weight, so I can get a bigger range for the same battery. At the same time, I'm also focused on achieving my carbon target by 2025 or 2035.
So are there any like guidelines to like where like this amount of carbon needs to be in this kind of car like by the government or like any policies, or is that all by like their own companies itself?
So they don't have a stringent law, but they do have an overall target. So when we calculate carbon footprint, so we have a standard. So there's a process called LCA, life cycle assessment. So what it does is you can Google it, you'll find it. I don't remember the exact standard. I think ISO 41111, something like that. So what it does is, or you can type in just life cycle assessment, LCA. So what it does is when you start building a car, it is not that you're building the car directly in the assembly line of an automotive industry. So you need steel panels. So in order to manufacture steel panel, you need to mine steel. So your carbon footprint starts from the area where it is start to mine. So that is the starting point of your uh, the whole. That's why we call life cycle assessment, the whole cycle, end to end. And it is not like after you're done with the car, when you put it in the junkyard, there's no more carbon. So you need to recycle all the recyclable items in the car. It can be battery, it can be whatever it is. So when you do that, those industries also are also going to emit emission. Correct. So those carbon footprint has to be incorporated. So that is why we call it life cycle assessment, end to end. So can I share my screen?
Yeah, of course. Go ahead. Go ahead.
You have disabled it. You
Oh,
need
I
to
have to just let me allow me. I think you requested um,
so there will be a bottom near chat
near the
where you
chat.
can
Oh,
you got to enable it.
yeah. Let me just enable it. You
Yeah, I got it.
got it. Okay.
Yeah. So this is what we call it, life cycle assessment. So it will include production of that particular component. Can you see my screen, Samara?
Yeah, yeah. I can see it.
Yeah. The production of that component and how exactly it is being processed, how exactly it is moved. For example, if it is a gasoline, you got to move it from the production to the fuel line. If it is a EV vehicle, from the production to the charging station, and then and how much does it consume throughout its lifespan of 20 years, 100,000 miles, 200,000 miles, whatever it is. And when you try to recycle those components, what would be the power consumption and the emission during the recycle. So this whole cycle we calculated and then we publish it. So this is what overall target is what the government try to track. So as an automotive, you are focused only on your automotive vehicle, but government tries to track it everywhere. Just to give you a background on how does your government track all those emissions and so on.
So, what part of the life cycle would you say is like the most affecting the carbon footprint? Is it the starting, the middle, or the like the end? More like the recycling part.
So, so currently we don't have a lot of data on the recycling because currently most of the vehicles in the EV sector has started back in 2014 and around that area. So we don't know a lot about recycling. Currently, the focus is predominantly on the utilization. For example, how can I reduce carbon footprint? Because when you move from ICE to BEV, that is internal combustion engine to a battery electric vehicle. What you see directly is you don't the EV vehicles does not have any direct emission, right? So this is the areas which we are currently focusing a lot, and this is the areas that is going to see tremendous improvement in the coming 5 to 10 years.
Yeah, so you said that how you don't have that much research on it right now because EV vehicles only started in 2014 and like more popularized now. So how do you gain that like kind of research and like technology for you to make those like decisions of whether to do this for the car or something else to reduce the carbon footprint?
No, we so this so that so only this part
Oh,
is
okay.
new. Only this part is new to us, right? The charging station and the battery electric
Mhm.
vehicle. But the rest are going to remain the same. The production are going to remain the same. How you going to build it is going to remain the same. How are you going to recycle a battery? Previously, I was recycling a battery, but it was a smaller one, different chemical composition. Now it's a different one. So everything has remained the same. So even though this is new to us, and this we are starting in the past 10, 15 years now, but the rest of the industries are the same. So I do have a lot of data to back me up on the rest of the areas in this industry.
That's great. So, can you share any like examples where like you really made a difference in a car's company in a company's car where they previously had a kind of a big carbon footprint with that specific car and you kind of changed that a little bit and like made it more optimizable for both the environment and maybe even like financially?
Right. So if you look at the Euro norms back in stage one, they are the one who brought it along with the US norms. So when they brought it back, like 20 years back, we were almost 20-30% higher than our current vehicles we have now. So I'll give you an example. So previously, when you build a car, say you build a car in Michigan, right? So what do? You have a lot of uh, heat emission because you need to do a lot of painting, a lot of assembly. You have a lot of heat emission direct in the floor. Previously, all those heatings and emissions are all let go out, meaning that they go directly in the environment. Now, what we do is it is not kind of a recycling, but an effective utilization of the heat, where we use those heat to heat the rest of the office, the other buildings, meaning that we are trying to incorporate effective utilizations of our energy and can be recycled multiple times. So we have more modernized factories now. And then you have seen the evolution of EVs.
Yeah.
So, and then now we have new ways of recycling a huge battery, lithium ion battery, all those electric components. So, meaning that now we have developed efficiency in all these three stages: production, utilization, and recycling. This has helped down to reduce the overall efficiency. We have increased the efficiency by 30%, which would have directly uh, uh, benefited the carbon footprint at least by 25 to 30% in the last 20 years.
Yeah, that's amazing. I think that's a very smart way of recycling your heat for like a different use. And what are some of like the challenges that you faced like working in this field? Because of course some people might not just care enough for the environment to do the same things your company is doing to care about the carbon footprint. So what are some challenges and how did you kind of overcome those challenges?
The challenge is again the cost. So can I go carbon neutral in 2030? Yes. Can any company wants to do it in 2025 or 2030? Yes, they can. But the problem is cost. So for example, like I said that if I build a vehicle with very least carbon content, the cost is going to be you'll end up in a higher side. So instead of me building a $35,000 vehicle, the vehicle will be $75,000. So it will become the affordability will be pretty low. So I might not do a high volume of sale. So that is going to hurt us. So we need to, the major challenge is the cost. That's why we take a linear uh, reduction of carbon footprint than going after the final target. And other thing is nobody can say at this point that they don't want to go take that route because we have standards both in US and global automotive sector, which we need to meet at some point. You can meet it at 2035. For example, uh, JLR recently made a statement that they're going to start electrifying all their vehicle by 2025, and then they're going to go after carbon neutral by 2030 35. So 10 years for both their utilization as well as production. So it is individual. So everybody is going to go after at some time. It is just cost.
Just the cost. So it's not if it's gonna happen, it's like when it's gonna happen now. And yeah, so what are some advice you could give for like younger students who are more interested in this field of environmental science and carbon footprint, or like people who are just started working in this field? What are some advice you can give them?
And understand the end application. So meaning that what you're going to do now, so we can I have done a lot of research in my studies back in my student days, and where I was able to start making differences once I start understanding the end application of your studies, and try to incorporate it throughout your studies, saying that, hey, this is what I'm going to do. For example, it is not just carbon monoxide, right? So you have NO2, nitric dioxide, that is NO, nitric oxide, there is acrolein, there is benzene. So there is a lot of outputs which you can go after. Not even though carbon monoxide is a major component, there are a lot of things you can do on. So if yeah, you should what you should look at, say, if there's a lot of studies done in carbon, is it a cost effective at the end application? Uh, yeah, there are other equipment where I can reduce acrolein to a very minimal. There is no cost to the for the cost of the car. So this there is a chance that they'll be able to implement this idea immediately. So whenever you do something, whenever you work on something, try to understand the whole series of items that is going to happen. So you'll understand that even though it is only 10%, but at the end application is going to be less than 10% cost. So there is a good chance that this idea will go through. So a lot of R&Ds, a lot of student works, um, it is people don't incorporate the cost and the end application. That is why they are not able to push it from a prototype to a production. It will still be a concept and will end up as a concept or a prototype.
So yeah, so you've stated multiple times like the cost is the most important part and the end aspect. So do you think people like right now do not value the end aspect of some of these productions, or they
They
just
don't
don't see?
they don't incorporate it. They don't incorporate it currently because so you have a problem, right? And then so for example, when you take up a program, when you take up a project, when you take up a thesis, you have a problem statement. You're trying to find a solution statement. So that is your biggest pain point. So you don't look at cost because if it is higher cost, lower cost, your solution is going to be the solution for the problem. And then whether it is practical or it is just a virtual concept, you don't know, but you don't focus on that. The biggest problem is we need to. So that is why education and industry should go hand in hand. So people understand that, hey, this is what I'm studying, and this is what this study is going to help me in the future. These are studies that are going to help these industries in the future. So that's why I keep talking about cost, because unless you say that, hey, there's tremendous value for this product, but the cost is going to be 50% higher, you will never get it through. And then, hey, this is a really good product, but the amount of usage for this product is 1%, it is going to never get through. So there are a lot of multiple parameters there, but cost and the end application is on the top.
Yeah, so to get to these end aspects, what are some like new technologies and like innovations you think you will see like emerging in your field to like help you get to this end goal that we're talking about? And yes, that.
So now we are trying to innovate ways of manufacturing a car. So the car that has been manufactured now, this is the methodology invented by Ford back in 1920s, the way how a vehicle is manufactured now. Now the new companies like Tesla, uh, and new innovative companies from China, they are bringing in a lot of new innovative manufacturing techniques that is going to not just evolutionize the manufacturing process, the design process of the whole vehicle. It is going to revolutionize the way a car is built. Um, so you need to think, when you think of ways to optimize uh, uh, these studies, you need to look from both evolutionary way, where what I can do tomorrow, what I can do in next year, short term. Those are all evolutions which you can make. And then you look at revolutionary studies like the car has been built like this forever. I'm going to bring in a new methodology. but that is going to totally revolutionary way a car is built, a plant is built, how the product is recycled. So those kind of highly new innovative methodologies is what is going to make major changes in this process.
So you think like the methods of how you do is more important than the new technology, I would say, because that's where it starts.
So new methodology supported with technology. So your primary is going to be the methodology, but the technology is going to be your supporting pillar. So you need both.
Yeah, so going on to the more end goal and like incorporating our community, how can like individual people and like people in our community combine with like companies, industries to just like overall um help our air pollution and promote this environmental sustainability of decreasing carbon footprint? Like how can we as like just regular people help this big goal end goal?
Now, people, it is basically they need to educate themselves. Um, for example, uh, there is a lot of green energy. Electrification of a vehicle is just one way, right? You can take solar panels. That is uh, that is going to give you 15, 20 years of free energy, no cost addition every year. So what are all we people needs to get educated from a green energy standpoint. So that is what they need to do. They can implement it, not implement it. That is different. We cannot push somebody and say that hey, you need to drive an electric vehicle to save the environment. You need to. So there is a lot of limitations in that because we don't have a charging station infrastructure that is going to support electrification throughout North America. So it is going to take some time, but there are other ways where we can go green from a recyclable standpoint, solar panel standpoint, and so on. So we need to educate the people, and people has to get educated so that they know that we've been doing this for the past throughout the life cycle. There is a different way to do it. Let's get educated. Can we implement it? Maybe, or it might not be a feasible option now. So that is something people needs to get educated right away.
Yeah, so of course we need to educate them and like for the end goal in the future. So how do you see like your field kind of reforming the policies and the goals of like maybe the government or like our general world right now in the future? Because of course, as you were saying in 2035, we need to have a certain carbon footprint to still be like living on this world and being having a safe environment. So how do you see like your field kind of connecting and collaborating with like the world's and the government's policies?
So we are incorporating it in every stage of a product development cycle. So previously, um, a government has uh, energy national energy reform where they focus predominantly on it. The FDA has their nomenclature and so different government organization has a different definition from a carbon standpoint. So previously, every company had a department for focus predominantly on the end carbon footprint. Now, what we are doing now is we are trying to change that methodology in such a way that it is not just a one team job, but it is a job of everybody who is involved in that product development. It can be a design engineer, it can be a manufacturing engineer, it can be a prototype manufacturer. So in this such a way that you will incorporate carbon footprint just like previously when you go to a design guy, he will try to build a design vehicle to help the crash guy that this will pass the crash. It will pass the in noise vibration requirements. It passes the assembly because there is no interference when they try to assemble. So all they worried about that. Then they started worrying about how do we make it lightweight so that if I put a battery, I get a 500-mile range instead of a 300-mile range. If you put a 100 kilowatt battery on a 2000 kilogram car, it will run for 300 miles. If you put the same 100 kilowatt hour battery in a 1500 kilogram vehicle, it is going to run for 400 miles or 430 miles, right? So you lightweight the vehicle, so you get a wider range, a broader range for the same cost of the battery. So they are trying to incorporate lightweighting, right? And then they started incorporating cost. Now we are trying to build in carbon footprint such a way that it is you lightweight it, you go for an optimal lightweighting, you go for an optimal cost, and also you incorporate carbon footprint in such a way that it is not going to end up in increasing, and it is going to go towards the overall company target. So that is what we are trying to incorporate into our programs, and that is what we are also presenting it as our findings. And this, if OEMs do that, I think at some point they will do that, and it will be a lot more easier process than we doing everything and then one guy trying to compress it everything together.
Yeah, so of course, expanding these policies would make your job a lot more easier and a lot more other people's jobs easier. And so, just talking more about like the overall electric vehicles in like our country, how do you think like the integrating of like electric vehicles into public transportation will help us? And do you think it's a good idea? And how far off do you see in the future happening?
Yes, so that is we need to do electrification is one way, especially for example the public transportation, the school transportation, everything. If because those are the areas um, where it is an urban environment, right? Meaning that these emission to get dispersed in the air and get because air is a great our environment as built, it is a good pretty good filter. But what happens is it is like it is a filter, right? So if you pour more water into a small filter, it is not going to filter a lot, it is going to go through some of this thing. So we need to clear the main advantage of when you look at the production of an electric vehicle versus an ICE vehicle, the carbon footprint is going to remain the same. But when you have an electric vehicle, the emission is pretty much controlled and defined in an urban areas, meaning that you are not going to have a huge carbon monoxide output measurement when a vehicle is full of EVs compared to a mix or predominantly ICE. So we need to push that hard, and what will happen is they are looking for a better infrastructure and then better range. If you can build that both, I think electrification in urban, especially for public sectors, school sectors, it is going to be a lot more faster than we anticipate.
Yes, of course. And so as you were talking about these sustainability movements to like kind of measure this carbon footprint, I know you talked about you're talking about the measuring the carbon footprint like through like the life process. Is there any kind of like number you use or like measurement you use to measure carbon footprint to
Yes,
like kind of see how much you progress from the start point to the end point?
yes. So there are a lot of tools available in the market, uh, which will help you with the measurement. Like, uh, for example, if you take, we have done a lot of studies on Tesla. So Tesla is a vehicle which has one of those pretty low carbon output because the way the vehicle is efficiently built, uh, and there are a lot of other vehicles that is coming close to Tesla, especially the new electric vehicles. So we use a lot of tools like grid. There are tools like uh, um, let me check real quick. Yeah, there are tools like we use tools like Grid, Blast, Autonomy, and there is one more tool which we use where these guys will help you uh, calculate it because we have all the inputs we need. So the inputs you need is what is the vehicle you're going to do, what is the parts, what is the weight, what is the material, what is the manufacturing process. When you input all those into a tool, that will help you give you the end carbon output calculation and so on. So those data are there are a lot of tools available which are pretty accurate.
So do you use these numbers and like are you talking about a graph about how to make it the most optimal between like money and carbon footprint? So do you use these tools to measure this kind of thing and like see oh which is the most optimal method to get this least amount of carbon footprint?
Yes, so when you have options, then that is where we use the graph to give an optimal one. For example, um, I manufacture a door. It has a steel door, aluminum door, composite door, so magnesium door, whatever it is. So then I know what is the cost to do it, what are all the other complexity factors, what is the carbon footprint. So when I put in all those things and then when I map it as a graph, I will have multiple data points. I can take a route which is my target. For example, I cannot define it, but OEM can define it. So, for example, you are building a EV which is $50,000, right? So, and then if the whole vehicle is $50,000, your production cost should be less than $40,000 or $30,000, because then you add up a lot of cost on the top of it that will add up to your vehicle cost. So when when you have that target, then you can say that for to achieve that target for the whole vehicle, for this system, what is the percentage, then I'll know what graph I should take. So based on your end goal, you'll be able to take the right graph to go against.
Okay, yeah. So now we're talking a lot about how electric vehicles definitely do help pollution, but what do you think about the indirect pollution caused by electric car batteries? Like, do you think it's very serious and severe, or do we need to kind of like just keep on going with the car batteries?
No, so there is a definite uh, carbon footprint. That's what I said. From a production standpoint, Uh, sometimes EVs carry more carbon footprint than an ICE vehicle because of the usage of rare earth materials, extensive usage of compositions, chemical composition for the batteries. So these will lead to higher carbon footprint output for the BEVs compared to ICE. Um, but like I said, this is an electrification, electric vehicles, battery electric vehicles. These are all new for us, meaning that we have 15 years of background, maybe 20 years of extensive studies on these vehicles. ICE vehicles, we've been doing it for hundreds of years. 1920, we have an extensive process to manufacture a car. So the it this will so currently it looks the same. Sometimes BEV looks bad, but as we move 5 years from now, there will be a lot of new technologies, new innovation that is going to help them bring it down. So it is going to take time, but definitely we are on the right track. So my statement will be currently it looks the same or sometimes bad on paper in terms of data, but since it is a new technology, 15, 20 years old, it is going to take time till we get a better way of doing things.
Yeah, you were talking about how there's gonna be new technology now, like upcoming the next 5 years to improve this electric vehicles. Have you seen any new advancements made in the battery packs for
Yes,
cars
yes,
in like Tesla,
yes.
maybe China?
Yeah, so not yeah, every OEM, if you look at that, back in 2014 to 2016, the usage of rare earth materials were higher in those chemical compositions of those batteries. But if you look at the latest vehicle, now we have LFP batteries, we have new cell chemistries in the batteries that is coming in 2023, 2024, and so on. These have a very minimal amount of rare earth material. So meaning that the battery cell technology has made a lot of new innovation. This helped them with reducing those usage of those materials and use materials which are easily available, easily accessible, low cost. So these kind of innovation is going to what is going to help them. And I am aware of a lot of new innovations in the battery that has been currently going on. That is going to really help us uh, make tremendous changes or tremendous strides in the coming 5 to 10 years.
Yeah, of course, but we can talk about how we need to increase the amount of electric vehicles. Not the it's not the solution right now, like not a direct solution, but of course there's still only a small percent of America and the world, like only 1% I think so, of the world that uses electric vehicles. And why do you think people shy away from electric vehicles and stay with the regular ICE vehicles like we were talking about?
It is predominantly we call it range anxiety, because when you drive a vehicle with an electric, you're worried about uh, say for example you're going to from A to B, and then you have a 300 miles range vehicle, and your distance is say 270. um, you have a range anxiety because you don't know. you will get a fuel station every 5 miles. You don't have a charging station every 5 miles. So if you miss a charging station, you might get a next one in 10 miles. It might not be next available in 30 miles. So that is what people are really concerned about. Um, and the second thing is, uh, when you drive a vehicle in the summer, if it says 300 miles, if you drive the same battery electric vehicle in winter, the efficiency goes down by 20% or 30%, meaning you'll get only 200 miles range. So uh, that that really scares a lot of people because they are worried about it. So till you build a vehicle that gives you an optimized performance throughout the year, till you get a proper charging station, the infrastructure is such a way that you get a charging station every mile, and then till you bring down, for example, you go from A to B, and then say it is a 3 hour drive, right? You're going to plan 3 hour, and or maybe 3.5 hours, including the break you're going to take. Imagine if you're driving an electric vehicle and then you need to pull over for a charging station. It is going to take 20 minutes to charge. And then, so now the time is going to go up, right? Your overall lead time is going to go up. So what you do is you need to plan 4 hours. So some lot of people cannot plan ahead. They don't want to do that. So there needs to be more uh, advancements done in the charging infrastructure, battery performance throughout all seasons of the year, and then latest technology of charging. So till we incorporate those 3 to 5 parameters, those are all the key things, key negative people think of. I don't know when they decided to go for a battery electric vehicle. So last year in the winter storm, people cannot even finding because the batteries are so dead that your home charging infrastructure was not able to charge it. So people has to tow their vehicle to a nearby supercharging station to charge it. And then and since a lot of people took that route, there was not even enough available charging station in the supercharging station, so that people has to wait in line. They need to push the vehicle. So these are things that scares them to buy another electric vehicle. These are things people see. When you see that, you'd be like, oh my, I'm not going to I'm not going to buy that. I'm not going to push my vehicle in a winter storm. So these are things we need to take care of in the coming future.
Yeah, with all these like cons to electric vehicles, so that obviously not that many people are buying electric vehicles, do you still think it's making a big enough impact on the world's environment right now? Or do you
Yes.
think we're still progressing for that impact and we're still like using baby steps to get up there?
So if you look at 2023, um, you can look at the exact numbers. The percentage of BEVs sold in North America, in the States, is around 6 to 7.5 percentage. You can document an exact number. So previously it was 2 to 3% in 2020 and so on. That is a huge jump. And then this thing is going to take a huge jump in by 2030, sorry, by 2025 to 2030. This is going to double, meaning that we'll be 15 to 20 percentage of the pure battery electric vehicle in the next 5 to 10 years. So we're going to take that route. Eventually everybody is going to do it, um, but we need to fix those cons before we do that.
Yeah, of course. And I have a couple more questions, and then I think we'll be done here because you've done a great job in talking about everything. But what are some like factors that like big car manufacturers like Ford, Toyota, and all these big companies are doing to kind of like push electric vehicles into their audience and target market? And do you think they're doing a good enough job? Do you think it should be um advertised more, or do you think they're doing a good enough job to spread these electric vehicles to their audience and like customers?
All OEMs internally, they are 100% aligned. If you look at every vehicle, every big OEMs, um, in 2020 they have 80 percentage of their budget for ICE vehicles, 20 percentage for battery electric vehicles. If you look at 2023, it is 60% for ICE vehicles, 40% for battery electric vehicles, meaning that They know that this is going to be the future. So I'm going to invest close to half of my resources, half of my budget for these kind of development. Pretty much every OEM globally is doing that. So internally, they are 100% aligned. Um, where there is a backtrack is, for example, they have built a lot of vehicles. For example, if you look at work trucks, so they build a vehicle which is cost optimized, 300 miles range, right? Um, when they try to tow vehicle to the max capacity, their range is 100 miles, 80 miles, meaning that the guy has to stop. Previously it is 300 miles, he's going to stop twice before he reaches. So normally trucks, when they tow, they go for 500 miles, right? So when they try to tow it with the 300 miles, when you do a full capacity towing, the range drops from 300 miles to 100 miles or 80 miles. Now we need to charge it every 1 hour for 20 minutes. So that is hurting their traditional customers. They are not going to do that. We are not going to. Even if we are going to do that, we are not going to do that. So the so they are investing it. But what is the workforce that is currently using the ICE vehicle? They don't get the same benefit from a battery electric vehicle unless you build a vehicle that has 1,000 mile range. Even with the full capacity, you have a 500 mile range, and then 1,000 mile range, it is going to give you a huge battery, huge cost. So you need to bring down the cost, increase the range, maintain the range with the higher efficiency. Till all these major OEMs do that, customer will not 100% back it up. Even I got a hard stop in 2 minutes. If you got
Yeah, yeah, of course. That was
any
the
other
last of
question,
my questions.
okay.
So thank you so much for this
Y- I
time.
I got 2 more minutes. If you have anything, I can sum it up.
My last question was like how you could kind of collaborate with like public health officials. Do you guys collaborate with like, cause they of course are research a lot about this topic, and you're more about the cars section. Do you guys collaborate in any way to kind of like combine your research and your
So,
thoughts?
so currently we work with organizations like IAHS, NHTSA, NCAP, and so on. It's predominantly on the safety of the car. We got a lot of data which will support them to analyze their crash ratings and so on. So those are all the organizations currently we work with. We don't we don't work with uh, FDA or any other health and safety related organization as of yet. I don't think we will work with them in the near future too, because uh, we we are kind of in a triangle where we support the part where OEM gets a benefit, OEM understands the carbon footprint target, and how we can help them directly and indirectly. And these people are going to work with the OEM. So even though we do our part, we might not have direct coordination with them.
So it's a good relationship right now between the companies and the federal like FDA and everything.
They are they need to be, because they need to get certified on their new vehicles on the norms. Now we have pretty stringent norms. It might get relaxed a bit, but they need to have a good relationship with them.
Okay, thank you so much for joining this Zoom meeting and educating us.
No
I
problem.
will end it right now. I hope you have a good day. Thank you so much.
If you need any data